Hi everybody, this is Ms. Peerboom again. Welcome back for the second day of Learning Target 14B on scientific notation. So yesterday we looked at how to write numbers in scientific notation or how to change them back into standard form. And so now we're going to take a look at how can we use scientific notation to quickly and easily do some calculations. And so we're going to talk first about how to multiply two numbers in scientific notation, and then we'll talk about dividing. Okay, so let's say I wanted to find the product between these two numbers that are both written in scientific notation. So I have 4.5 times 10 to the third, and I'm multiplying that by a second number in scientific notation, 6.3 times 10 to the seventh. Okay, so the whole idea with scientific notation is that it should make it very easy to write numbers that are either really big or really small, and then to also make calculations a little bit easier to do as well. So to do this, we're going to first rearrange our numbers so that we have the number 4.5 times the number 6.3. So those numbers out in front, we're going to put those together and multiply them. We're then going to take our two powers of 10 and we're going to put those together to also be multiplied, since we're taking one product times another. Okay, so with your calculator, we can type in 4.5 times 6.3, and that's going to give me 28.35. So you can check that on your own calculator. Then I'm going to try to multiply my powers of 10 together. So if I'm multiplying by 10 3 times, and then I'm multiplying by 10 7 more times, total I'm multiplying by 10 10 times. And so the trick here is that we can add the exponents on the powers of 10. So when multiplying in scientific notation, we multiply the numbers out in front together and then add the exponents on the powers of 10. So 3 plus 7 means my new exponent is 10, so 10 to the 10th. Then, once you've done that, we need to then check to see if our answer is actually in scientific notation or not. So is 28.35 times 10 to the 10th actually in scientific notation? Well, unfortunately, it's not, because I have two non-zero digits to the left of the decimal. So that means I need to think about what would this number be expanded out. So if I move the decimal back 10 times to the right, it's going to look like this. Okay, and so to get it into proper scientific notation, I need the decimal to be between the 2 and the 8. So I need to move it 3, 6, 9, and then 10, 11 times in order for it to be in the proper place. So my final answer should be 2.835 times 10 to the 11th power. And so again, when we first did that calculation, the decimal wasn't in the right spot. They didn't move, it wasn't quite far enough over to the left. So we move it once more over. That's going to increase that exponent up to 11. But again, I think it's easier to think about what it is in its expanded form or standard form, and then figure out how to rewrite it in that scientific notation. All right, let's try another one. So 1.25 times 10 to the fourth times 7.6 times 10 to the second. Okay, so first we'll rearrange it so that we have the numbers out in front multiplied together, and then our powers of 10 grouped together. So 1.25 times 1.25 times 7.6 on your calculator, that's going to be 9.5. 10 to the fourth times 10 to the second, that's going to be 10 to the 6, because we add the exponents. So 4 powers of 10 and then 2 more make a total of 6. And so then the question is this actually in scientific notation? So I've got a number between 1 and 10 times the power of 10. So I would say yes, that's my final answer. All right, let's try one more. So 8 times 10 to the negative fifth times 5.65 times 10 to the negative fourth. Okay, so in this case, we have negative exponents, but that doesn't change anything about the way that we actually calculate our values. So we're still going to rearrange it so that the number in front are together and then the powers of 10 are together. 8 times 5.65 gives me 45.2. 10 to the negative fifth times 10 to the negative fourth. When we add those exponents together, negative 5 plus negative 4 makes a total of negative 9. Okay, so now that we've done that calculating, we have to check again, is our answer in scientific notation? Again, our answer is going to be no, because I have two non-zero digits to the left of the decimal. So think about when I expand that out. Since my exponent was negative 9, if I grab the decimal and move it 9 times back to the left to make it a really tiny number, and then think about where I want the decimal to be, I want it to be between the 4 and the 5. So in that case, I only need to move it 1, 2, 3, 4, 5, 6, 7, 8 times. So it should be 4.52 times 10 to the negative 8th power. All right, so now that you've seen a couple of examples, I'm going to have you guys try to answer each of these, and then when you're done, you can continue forward to see if you did them correctly. All right, so the first one, hopefully you multiplied 3.1 times 2.8 and then added our exponents, so negative 6 plus negative 4 is negative 10, and since 3.1 times 2.8 is 8.68, this is in scientific notation already, so that would be your final answer. Okay, the next one, 3.2 times 10 to the 4th times 4.1 times 10 to the 8th. So 3.2 times 4.1 is 13.12. Adding my powers of 10, adding the exponents together, that gives me 10 to the 12th. However, this is not in scientific notation, so I need to move the decimal over to be between the 1 and the 3, and my exponent is going to go up to 13. So 1.312 times 10 to the 13th power. Okay, so now that we've done some multiplying, let's take a look at what happens when we divide in scientific notation. So this process is going to be very similar. The difference is going to be what we do with our exponents on our powers of 10. Okay, so let's find the quotient between 8.4 times 10 to the 11th divided by 3.2 times 10 to the 5th. Okay, so I'm going to rearrange it again, moving the numbers in front together and my powers of 10 together. Now notice that I'm dividing 8.4 divided by 3.2, so I'm dividing here, but then my answer to that is still going to be written in scientific notation, so it's going to be times whatever my result is from my powers of 10. So 10 to the 11th divided by 10 to the 5th. Okay, on your calculator, 8.4 divided by 3.2 gives me 2.625. And then with our powers of 10, rather than adding like we did for multiplying in scientific notation, since we're now dividing, we're going to do subtraction. So subtract the powers of 10, and that's going to give you 10 to the 6th power, because 11 minus 5 equals 6. Okay, so once you have that, then we can check to see, is our answer actually in scientific notation? In this case, I believe it is, and so that would be our final answer. Okay, let's try another one here. So find the quotient between 1.5 times 10 to the 4th and 6 times 10 to the negative 5th. So we're dividing these two numbers. Okay, so start by rearranging it. So 1.5 divided by 6 times 10.4 or 10 to the 4th divided by 10 to the negative 5th. So group the numbers and then group the powers of 10. Okay, so let's calculate here. So 1.5 divided by 6 is going to give me 0.25. And then for my powers of 10, I now want to use subtraction. So when we were multiplying in scientific notation, we added the exponents. When we're dividing in scientific notation, we subtract the exponents. So 4 minus negative 5 gets rewritten as 4 plus positive 5 for a total of 9. So be really careful with our negative values here. Okay, so then ask ourselves, is this in scientific notation? I would say no, because I don't have a non-zero digit to the left of the decimal. And so when I think about this number expanded out, it's going to be 250 million. And so rewriting it in scientific notation, I need the decimal between the 2 and the 5, which means I need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8 times. So 2.5 times 10 to the 8th power. All right, and for one more example, let's take 7.6 times 10 to the negative 4th divided by 9.5 times 10 to the 7th. All right, so like in the other examples, let's rearrange it and regroup. So 7.6 divided by 9.5 gets grouped together, times, and then group my powers of 10, so 10 to the negative 4th divided by 10 to the 7th. All right, on your calculator, 7.6 divided by 9.5 should give you 0.8. For my powers of 10, remember I'm going to subtract the exponent, so negative 4 minus 7 is going to give me negative 11. And then we check to see, is this in scientific notation? No, because I don't have a non-zero digit to the left of the decimal. So when I expand that out, it should look like this. So if I move the decimal 11 places back, and so thinking about where I want the decimal to be, I want it to be after the 8. So I actually need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So this would be 8 times 10 to the negative 12, because we're dealing with a small number. Therefore, we should have that negative exponent. Okay, so I'm going to have you guys try these two, and then you can see your answers or check them before you wrap up with reflection. Okay, so for the first one, you should have divided 7.5 by 1.6 to get 4.6875. And for our powers of 10, 10 to the 8th divided by 10 to the 5th, subtract the exponent. So 8 minus 5 leaves you with an exponent of 3. So 4.6875 times 10 to the 3rd power. And then number 2, 4.4 divided by 6.4 is going to give you 0.6875. And then for our powers of 10, 4 minus negative 4 becomes 4 plus positive 4, which gives you 8. And then we rewrite that as being 6.875 times 10 to the 7th power. Okay, so to wrap up here, please reflect on something you learned or were reminded of and a question that you have, either about the material or something you're wondering about. And that'll be it for today. Thanks for watching.